Hello. In this video, we're going to walk through the basics of the Rust programming language in a quick and completely hands-on way. We'll be using Google Cloud's Cloud Shell Editor, but feel free to use whatever IDE you prefer. To get started, you'll need to install Rust. The standard way to do this is using RustUp, which supports Windows, Linux, and Mac. Once installed, you can verify it's working by running the command rustc version. If you see a version number, great. Rust is properly installed on your machine. One of your best friends in Rust will be the cargo command. Cargo helps you manage packages, bootstrap your code, and run tests. Let's create a new project by typing cargo new fast rust basics. This creates a new folder with some important files inside. You'll see a cargo.toml file, which contains metadata about your package like the name and version, as well as any dependencies you might use. You'll also find a src directory containing main rs with a simple hello world function. Now, let's enter that directory and run our code with cargo run. This will compile our source code, remember Rust is a compiled language, and then run it. You should see hello world printed out. We can modify this println macro, the exclamation mark indicates it's a macro, to print something different. This particular macro prints a line with a new line at the end. After changing the text and running cargo run again, you'll see your new message. Next, let's explore variables and mutability in Rust. We use the let keyword to declare variables. For example, let x equals 5 creates a variable named x with the value 5. By default, variables in Rust are immutable, which means you can't change their values after they're declared. If we try to write x equals 6 after declaring x, we'll get a compiler error saying cannot assign twice to an immutable variable. If you want to create a variable that can be changed, you need to use the mut keyword. For example, let mut y equals 10. Now we can print y, change its value to 20, and print it again. When we run the program, we'll see 10 first and then 20. Rust is a statically typed language, but it often uses type inference, so you don't have to explicitly define the types. However, you can specify types if you want to. For example, let learning bool equals true. For a Boolean, let pi f64 equals 3.1415 for a 64-bit floating point number, and let letter char equals r for a character. Rust supports many data types, including signed and unsigned integers, 8-bit to 128-bit plus isize and usize, floating point numbers f32, f64, booleans, and characters. Rust even supports emojis and other complex non-ASCII characters. Strings in Rust are a bit more complex. String literals are immutable references to UTF-8 encoded string data stored in the binary. For example, let fixed string equals some code creates a reference to UTF-8 string data. If we want a mutable string that we can change, we need to use the string type with the capital S. For example, let mut mutable string equals string from hello creates a string we can modify. We can then add to it with mutable string push str rust, and when we print it, we'll see hello rust. Now let's look at functions in Rust. We can create a function outside of our main function. For example, let's create a greet function that takes a name parameter and prints a greeting. The function might look like this: fn greet name and str println hello name. We can then call this function from main with greet learner, and when we run the program, we'll see hello learner. Functions can also return values. Let's create a sum function that adds two numbers and returns the result. We might write fn sum a I32, b I32, I32 a plus b. Notice there's no semicolon at the end of a plus b. This means the value is returned. Back in main, we can call let sum equals sum5 3 and then print the sum is sum. When we run it, we'll see the sum is 8. Next, let's explore control flow with if-else statements. These allow us to execute code conditionally. For example, let age equals 18. If age equals 18, print ln, you're an adult. Else, print ln, you're a minor. Since 18 is greater than or equal to 18, we'll see you're an adult. If we change age to 14, we'll see you're a minor instead. We can also add more cases with else if, like checking for teenagers or children. What's unique about Rust is that if is an expression, meaning it can return a value. For example, let result if age 21, have fun, else go home. The entire if block evaluates to a string which we store in result. If we print it with age set to 14, we'll see go home. Now let's look at loops. Rust has a few different ways to create loops. First, there's the basic loop keyword, which creates an infinite loop that continues until you break out of it. Let's create a countdown timer. Let mutCounter equals 3 loop println counter counter equals 1 if counter 0 break. This will print 3, 2, 1 and then exit. Rust also has the while loop, which is similar but includes the condition directly. Let mut number equals 1, while number less than 5, print ln number plus equals 1. This will print 1, 2, 3, 4, 5 as it counts up until the condition is no longer true. The last loop we'll cover is the for loop. This is useful when you want to iterate over a range of numbers or elements in a collection. For I in 0, 5, print ln I. This will print 0, 1, 2, 3, 4. Notice that the upper bound 5 is exclusive, so it doesn't get printed. Before we finish, let's talk about compound types, tuples and arrays. These allow us to group different elements together. Tuples can contain mixed types. We can access elements of a tuple using dot notation, tuple.0 for the first element, tuple.1 for the second, and so on. Arrays, unlike tuples, must contain elements of the same type. For example, let nums equals 1, 2, 3, 4, 5. We can access elements of an array using square bracket notation, nums 0 for the first element, nums 1 for the second, and so on. These are the first concepts you need to know to get started with Rust. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all code in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching till the end, and please enjoy responsibly.